Our lesson today is going to cover two different things. One is the greatest common factor, and the other is called the least common multiple. So we will start with the greatest common factor. This is something that is abbreviated with GCF. You may see that a lot. It is used for numbers. If you get into an algebra course, you'll also be using it as one of the types of factoring polynomials. So the definition is that the GCF, or the greatest common factor, is the largest number, which is a factor of two or more given numbers. So we will be taking two numbers and trying to find the largest number that divides evenly into each of these numbers. So for an example, I've picked 24 and 36, and for these two numbers, what we'll do is we'll make, the first method is to make a list of the factors of every number. So a factor, again, is something that divides into the number. So I've looked at the number 24, and I've listed all of the things that go into 24. They are 1, 2, 3, 4, 6, 8, 12, and 24. So each of those numbers divides evenly into 24, and there are no other numbers between 1 and 24 that would work. Then I did the same thing for 36, and I got the numbers 1, 2, 3, 4, 6, 9, 12, 18, and 36. And again, those are numbers that divide evenly into 36 without a remainder, and there are no other numbers that would work. So now what I'm going to do is look through the list. I looked for common factors. So for common factors, there is 1 in both lists, 2, 3, 4, 6, and 12. And what we are looking for is the greatest or the largest one of those, so you can see that that number is a 12. So this is one way to find the greatest common factor, and that is to make a list of the factors of both of the numbers, or all three numbers if you have three in your problem, and just to find the largest one that's in common in each list. A second method is called prime factoring. So it's prime factoring is where you find all of the prime factors of the numbers. So in this one, I've taken two different numbers, 12 and 16, and I'm going to still be looking for the greatest common factor. First thing I will do is factor the 12 and factor the 16. So in order to factor the 12, I start by dividing by primes. So the first prime is a 2. So 2 goes into 12 6 times. I try the 2 again. 2 goes into 6 3 times. Now 2 won't go in again, but the number that I have on the bottom there is a 3. So if you look below, I have written 12 as the product of 2 times 2 times 3. Then I will do the same thing with 16. And in that one, 2 goes in there 4 times. So 2 goes into 16 8 times. I can do 2 again. That will be another 4 times. 2 again, and that will leave you a 2. And again, the bottom 2 is a prime, so I'm finished. So I rewrite that as 2 times 2 times 2. Now, notice when I wrote the primes, I wrote them so that only the same number occurred above each other. So the 12 has a 2, and the 16 has a 2. And then the next two sets of 2 are both common. But then after that, the 12 has a 3, which is not the same as any factor in 16. And then in 16, there's also 2 factors of 2. So I only line up the ones that are in common. And notice I've circled that there's a 2 in common for the first 2 factors. And then there's another 2 in common. So those are the only 2 that I use. So I bring both of those down. I only bring them down once. And so I use a 2 times a 2, so the greatest common factor is the product of those, which is a 4. All right, that means, again, 4 is the biggest number that divides evenly into both the 12 and the 16. So this is another way that you can do greatest common factor. All right, the other idea we're going to talk about today is least common multiple. Least means smallest, so this is the smallest number into which each of your numbers will divide. Okay, and my problem will be I'm going to try to find the least common multiple of 4 and 9. So again, I'm going to do two methods. One is to make a list of multiples. Now, multiples are things that our number divides into. So basically, you count by that number. So for 4, I count 4, 8, 12. These are all things. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. And I keep going with that number. And then I do the same with 9. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, and I keep going with that number. Now I have to keep going until I find something that comes up in common. So the first thing that comes up in common is the 36, And so 36 will be the answer. So you just keep going with this one until you find any number that they both go into. Okay, notice I went a little farther on both of those, but I could have stopped both of them at the 36. So 36 again is the smallest number that 4 and 9 will both divide into. Now we can also do that the other way, the prime factoring way. And if you look at this problem, it's very similar to the other one that I did. I still will find the factors of both of those numbers, just like I did before, and I will write them down. The difference here is when you do the least common multiple, you bring every column down. Okay, so the first column is 2 2s, you only bring one of the 2s down. Second column is 2 2s, bring only one of the 2s down. The third, fourth, and fifth column have one number each, a 2, a 2, and a 3, so you have to bring all of those down. Okay, and you multiply all that together, and the answer is 48. So again, this means that the smallest or least number that both 12 and 16 will divide into is the number 48. Thank you for listening to the presentation on GCF and LCM.